Hi guys, this is Notes 58. So today we're going to do something called dividing radicals. And it's pretty funky, but I think we're going to get the hang of it. So dividing radicals is just like multiplying. So we're going to divide, but we're going to do outsides with outsides, which we talked about today is called coefficients. So we're going to take the coefficients, the outside ones, and then we're going to also do insides with insides. So what that means, I'm looking at number 1 here, so I'm going to do my outsides. 12 divided by 2 would be 6. And then I'm also going to do the insides, so I have the square root, and I'm going to do 160 divided by 5. And so quick math, that's 3, 1 left over, 32. So 160 divided by 5 is 32. From there, the last step is to just simplify. So take that 32, break it into 8 and 4, which is 2 and 4, 2 and 2, 2 and 2. I'm looking for groups of 2. So I'd say this is a group of 2, and that's a group of 2. This one's going to multiply times that 6. This one's going to multiply times that 6. We're left with this 2 left over. So 6 times the first 2 times the second 2, and then left inside is a 2 by itself. So I have 6 times 2 is 12, times 2 is 24, square root 2. Alright, so we have a simplified version. So we see outsides with outsides, that's the blue part. And we see insides with insides, that's the orange part there. And then after that, it's just simplifying. So if I look at number 2, same thing. I've got outsides with outsides. 36 divided by 9 is 4. And then I have insides with insides. So I have the 4th root, and 1250 divided by 2 is 625. From there, I just need to simplify. 625 is 125 times 5. This is 25 times 5. This is 5 and 5. I'm looking for groups of 4 here. So I have these 2 and this one put together make 5 total. That's one group together. It's going to multiply times the 4 from the beginning. And then there's nothing left over, so it's just 4 times 5, which would be 20. All right. Number 3, we start to see our letters come into play. So I'm going to erase this part here. Make sure you've got it before I move on. Actually, I can do that. I'm just going to rewrite this here. The square root of x to the 6th over y to the 8th. So remember that we can write this as the square root of x to the 6th over the square root of y to the 8th. Those things mean the same thing. On the top, we can see that there are 6 x's, and I'm breaking them into groups of 2. That means that I would have 3 groups of x's with none left over. And then on the bottom, I have 8 y's. You can imagine there are 8 y's if you want. How many groups of 2 that would make? 1, 2, 3, 4 groups of y's, and that's x to, or y to the 4th. That is our final answer. Finally, for this one here, we have, I can simplify it to start out. So I have 3 a's on top, and I have 12 a's on bottom. And I know that these ones are going to cancel and leave me with 9 a's on the bottom. So if I'm going to rewrite this problem, I'm going to have the cube root of 40 over a to the 9th power. That's because these two cancel here, or simplify into a to the 9th. From here, I can do the cube root of 40 over the cube root of a to the 9th power. 40 turns into 2 and 20, which is 2 and 10, which is 2 and 5. I'm looking for the cube root here, so circle groups of 3. Here's one here, which is 2 on the outside, leaving a 5 on the inside. And then on the bottom here, I have 9 A's. And I'm looking for groups of 3. I have 1, 2, 3 groups of 3. So I have A to the third power. There's nothing I can simplify. So I have this as my answer here. So we do outsides with outsides, insides with insides, and then simplify from there. All right. Seems pretty simple so far, and probably not anything crazy new. But just like, I don't know if you guys remember this, but back in the day we used to have like 8 and we would have maybe like 4i on the bottom. And we weren't allowed to leave I on the bottom. In a similar way, we're not allowed to leave a square root of 3 there. So what happened here, we have a little bit of a story. Way before calculators, and time before calculators, mathematicians did not want to divide by a radical because if the radical is not perfect, we're dividing by an irrational number. So they used to have these big long books that said like the square root of 2 is 1.412 da 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 da, and it told you all the different numbers. And you had to divide by that number. It's a lot easier to divide by an even number like 2. Right? So they came up with a way to do this thing called rationalize the denominator, which means get rid of the radical in the denominator. So they basically decided that it was going to be a rule that this is not allowed. Right? They didn't want that square root to exist. So what we do, if we have a denominator like this, is we take the bottom and we multiply by the thing that we want to get rid of. In this case, the square root of 3. What we do to the bottom, we also have to do to the top. So we multiply across the top. 1 times the square root of 3 is just the square root of 3. And then we know the square root of 3 times the square root of 3 is the number 3. It's much easier to divide by 3 than by square root of 3. So we know that this is our rationalized denominator. Go ahead and ask any questions that you need to. And then we're going to look at this one. This is a 2. Sorry about the getting cut off. So I have 2 over 3 square root 10x cubed. So I want to get rid of the radical that's here. So I'm going to multiply by the thing that I don't want. 10x to the third. And on top, 10x to the third. What that means is that we would have 2 square root 10x to the third on top. Pretty simple. And then on the bottom here we have that 3. And then because we have both of these square roots, they cancel each other out. They cancel each other out. So we get times the 10 square root 3. Right, so these together are going to make a whole 10 square root 3. From there, I can multiply them. So I get 2 square root 10x to the third over 30x to the third. 2 and 30 can be simplified to 1 over 15. So I would have the square root of 10x to the third over 15x to the third. You might be thinking like, oh yeah, I can just cancel these like that. But you actually can't, and the reason is because this x to the third on top is inside of the square root, and this one is not. So there are 2 different numbers. So this is as simple as it gets. That's called rationalizing the denominator. You just multiply by the thing you don't want. Sometimes, however, you have something more